Building upon our limiting reactant discussion, we're going to discuss how to calculate the percent yield based on what we've been calculating, the theoretical yield. To accomplish this, we'll distinguish between actual and theoretical yields so we can calculate percent yield, actual yield, or theoretical yield given two of the three quantities or some way to calculate them. Let's begin. So far, we've been calculating the theoretical yield, or the maximum amount of product that can be made using the given amounts of reactants and assuming no loss of product. The actual yield of product is the amount of product recovered from a reaction. Unless you're weighing wet product, the actual yield will always be less than the theoretical yield. This could be due to an incomplete reaction, product loss to the glassware or filtration paper, or plain old clumsiness resulting in dropped bits of product. Reactions in the lab almost always require a percent yield calculation to see how good the technique was, or to see how far to completion the reaction went. We calculate the percent yield by dividing the actual over the theoretical and multiplying by 100%. Let's work through an example to demonstrate. The beginning of this question is just like what we've been practicing. We have a balanced chemical equation, so the next step is to convert the masses of reactants to moles of reactants. Next, determine the limiting reactant based on which reactant produces the least amount of product. What is the maximum amount of product that can be formed? This is our theoretical yield. Divide the actual yield by the theoretical yield, then multiply by 100% to get the percent yield. As always, I'll leave you with the parting thoughts of the authors.